Hello, my dear student. In this video, we will be talking about first, if-then statements. Second, the truth value of an if-then statement. And third, converse, inverse, and contrapositive statement, which were taken from the module titled Introduction to If-Then Statements by Isa R. Bitanga. After this video, you are expected to determine the relationship between the hypothesis and conclusion of an if-then statement, transform a statement into an equivalent if-then statement, determine the inverse, converse, and contrapositive of an if-then statement, and illustrate the equivalences of the statement and its contrapositive, and the converse and inverse of a statement. The pictures here show an Excel formula, properties of equality, research hypothesis, song and code, parking rates, and product slogan, which presents different situations with conditions and their corresponding results. These are just some of the many real-life applications of conditionals, which are sentences that present situations and their possible outcomes. Now let's move along and get to know more about conditionals. Let's have now our first lesson, the if-then statements. When we say if-then statement, take note, this is also known as the conditional statement. It is a statement that gives a condition and the outcome of that condition. So there is a cause and effect relationship. It is composed of two clauses, namely the if clause denoted by small letter p and the then clause denoted by small letter q. Given the variables p and q, it's in the form if p then q. P statement is called the hypothesis. It's the condition. And the Q statement is the conclusion, the outcome of that condition or the outcome of the hypothesis. Let us have examples. First, I will save the environment by recycling bottles, cans, and paper. So first, let us determine the hypothesis and the conclusion of this statement. Take note, the hypothesis here is the condition. It does not necessarily mean that a hypothesis comes first before the conclusion because some conditional statements are not in the form if then. Now, if the statement is not in an if-then form, then you cannot easily determine or you cannot conclude that the hypothesis is on the first part of the sentence. Like this example number 1. If we're going to study it, which comes first or which one is the condition? And what is the effect of that condition? So in here, the hypothesis is recycling bottles, cans, and paper. And what is its effect? We have, I will save the environment. So that's the conclusion. Now, if we're going to change this into an if-then statement, We just have to write the given sentence in the form if P then Q. But take note, we cannot directly use the hy- take note, we cannot directly use the statements or the phrases used in the sentence to form the P and Q statement. So after if, we must have a sentence. It must have a complete thought. We cannot say, if recycling bottles, cans, and paper. What will we use to complete that hypothesis? So since in the problem, the subject is I, so we're going to use the word I. So we have if I, we cannot use recycling, but instead we'll use recycle. So if I recycle bottles, cans, and paper, then I will save the environment. So that is now the if then statement. Second example, we have a squared minus b squared all over a squared plus 2ab plus b squared equals a minus b all over a plus b. Again, let's determine the hypothesis and the conclusion. For this statement, the hypothesis is this one. And the conclusion or the answer when we simplify the hypothesis, it's a minus b over a plus b. Now, how are we going to change it into an if-then statement? Take note, a fraction implies or a fraction bar implies division. Therefore, we can say that if a squared minus b squared is divided by a squared plus 2ab plus b squared, then the quotient is a minus b over a plus b. Let us have another example. In here, given already is the hypothesis denoted by small letter p and the conclusion denoted by small letter q. So we have here, Apayao is under typhoon signal number 2. In the conclusion, classes until high school in Apayao is suspended. So this is the hypothesis, it's small letter p, and the conclusion is the small letter q. Now changing it to an if-then statement, we have to use the word if before the hypothesis and q before the conclusion. So if I... Now, how are we going to determine the if-then statement of those two sentences? So we simply have to include if before the hypothesis and then before the conclusion. So we now have, if a payaw is under typhoon signal number 2, then classes until high school is suspended. So in here, we can cancel in a payaw since on our if statement, there is already the province of Apayao. So that is all about if-then statements or conditional statements. Let us now have lesson 2, the truth value of an if-then statement. Take note, not all if-then statements or conditional sentences are true. Some are false. Now, an evidence showing that an if then or conditional statement is false is called a counter example. We only need to find one example in which the hypothesis is satisfied but not the conclusion to decide or say that an if then statement is false. Let us have examples. First, if one eats properly and healthy and exercise regularly, then she or he will have optimal health. This statement is true, since some of the ways to have optimal health are healthy and proper eating and, of course, regular exercising. And we cannot find a counter example for this statement. Next example. If babies feel hungry or wet or want to be cuddled, then they giggle. Of course, this statement is false because when a baby feels uncomfortable or they want to be cuddled, they do not giggle. Instead, they cry. So it's a false statement. Example 3. If the sum of the measures of two angles is 180 degrees, then the angles are complementary. Can you still remember what are complementary angles? When we say complementary angles, these are pairs of angles whose sum measures 90 degrees. Therefore, this statement is false. A pair of angles whose sum of measures is equal to 180 degrees are called supplementary angles, not complementary. Another example, if a number ends with 0 or 5, then it is divisible by 5. This statement is true. A number is divisible by 5 if it ends in either 0 or 5. Last example. If it is a function, then it is a relation. Can you still remember the difference between a function and a relation? Okay, so since a function is a special type of relation, then that means this statement is true because all functions are relations, but not all relations are functions. So that's all about the truth value of an if then statement. Let's now proceed to lesson 3, the converse, inverse, and contrapositive statements. Aside from the if-then form of an statement, there are also three other conversion statements. We have the converse, the inverse, and contrapositive. Now, what's the differences of these four? For the if-then statement, we have the form if P, then Q. So the hypothesis is written after the word if, and the conclusion is written after the word then. But for the converse statements, it is formed by interchanging the hypothesis and the conclusion of the given if-then statement. So we now have here if Q, then P. If before the conclusion and then before the hypothesis. For the inverse statement, it is formed by negating both the hypothesis and the conclusion of the if-then statement. When we say negate, we take the opposite. So it's in the form if not P, then not Q. Then for the contrapositive statement, it is formed by interchanging and negating both the hypothesis and conclusion of the if-then statement. Or simply, the contrapositive statement is found by negating the converse of a given statement. So always remember, we have two I's and two C's. The inverse is taken by negating the if-then statement, and the contrapositive is simply taken by negating the converse statement. So two I's are paired and two C's are paired. Let us have examples. Let's consider the sentence, perpendicular lines intersect. So how are we going to change it into an if-then statement? We have to determine first the hypothesis and the conclusion. And for this statement, the hypothesis is perpendicular lines and the conclusion is intersect. So for the if-then statement, we have if they are perpendicular lines, then they intersect. This is the easiest way actually to change a given sentence into an if-then form. If we are describing a plural, we may use the word they. So that when we use that they, it should be used to both if and then statement. So we have if they are perpendicular lines, then they intersect. Now, given the if-then statement, we can now easily determine the converse statement. So we have to interchange the if and then. So we have to interchange the sentences after if and after then. So we have if they intersect, then they are perpendicular lines. For the inverse statement, we just have to negate the if-then statement, but it doesn't mean that in the form if not P, then not Q, then you write if not they are. You must include the word not anywhere on the hypothesis to make it the opposite. So if we write the inverse, we have if they are not perpendicular lines, then they do not intersect. For the contrapositive, we have to negate the converse. So we have if they do not intersect, then they are not perpendicular lines. Another example, a rectangle has four right angles. For the if-then statement, we may use if it is a rectangle, so we may use the word it, or we can describe what is that rectangle. So we may use a polygon, a shape, or a figure. So anything that describes a rectangle. So if a polygon is a rectangle, then it has four right angles. And then for the converse, take note if we use other words aside from it or they or he or she, then the subject must remain after the word if. You just have to interchange the predicate of the hypothesis. So we have if a polygon has four right angles, then it is a rectangle. And for the inverse statement, we just have to negate the if then or find or change the if then statement, take the opposite of the given hypothesis and conclusion. So we have if a polygon is not a rectangle, then it does not have four right angles. And for the contrapositive, we can find for the negation of converse statement, or we can interchange the if and then statements from the inverse. So we have if a polygon does not have four right angles, then it is not a rectangle. Last example. Good citizens obey rules and regulations. So in here, the hypothesis is good citizens, while the conclusion is obey rules and regulations. So for the if then statement, we have if they are good citizens, then they obey rules and regulations. For the converse, interchanging the hypothesis and the conclusion, we have if they obey rules and regulations, then they are good citizens. For the inverse statement, we have to negate the if then statement. So we have if they are not good citizens, then they do not obey rules and regulations. And of course, for the contrapositive statement, we just have to negate the converse. So we have if they do not obey rules and regulations, then they are not good citizens. So that is how to change or find the converse, inverse, and contrapositive statements of a given conditional or if then statement. Before we end this video, remember that when we say if then statement, it's a conditional statement with hypothesis and conclusion. And it's in the form if P then Q, where P is the hypothesis and Q is the conclusion. And always remember that not all if then statements are true. So to determine or to prove that a given if then statement is false, you must find at least one counter example. When we say counter example, it's an evidence showing that an if then statement is false. And aside from if then statement, we also have other three conditional statements. We have the inverse, the converse, and the contrapositive. For the converse, it's in the form if Q then P. Inverse is in the form if not P then not Q. And contrapositive is in the form if not Q then not P. That's all. I hope you have learned a lot from this video. Thank you for watching.